Namaste to everyone. I welcome you all in my YouTube video channel. Today, I will give you tricks to find the number of 1 functions. Now let capital A and capital B be two sets. Capital A contains elements A1, A2, A3. And capital B contains elements B1, B2. F1 be a function defined on A to B such that image of A1 is B1, image of A2 is B1, image of A3 is B2. So F1 A1 equal to B1, F1 A2 equal to B1 and F1 A3 equal to B2. Number 2. Here let A and B be two sets. A contains elements small a1, small a2, small a3 and set B contains elements b1, b2, b3. Let F2 be a function defined on set A to B such that image of A1 is B1, image of A2 is B2, image of A3 is B3. Therefore, F2 A1 equal to B1, F2 A2 equal to B2, F2 A3 equal to B3. Here we see that elements A1 and A2 has same image B1. That is, this side many elements, this side single element, single image. For many elements we get single image. So the function f1 is called many one function. In case 2 we do not get such type of images. For different elements of set A, we get different images. Here we get F2 A1 not equal to F2 A2 not equal to F2 A3. Also, A1 not equal to A2 not equal to A3. Means for distinct elements of A, we get distinct images. But here we get F1 A1 equal to F1 A2. This equal to B1. But A1 not equal to A2. A1 not equal to A2, then F1 A1 equal to F1 A2. So for many one function we get this property A1 not equal to A2 but their images may be equal. So for one function we will get just reverse. This is many one function, F1 is many one function. And this is 1 function. Means F2 is 1 function. In this case, we get just reverse result. If F2x equal to F2y implies that x equal to y. So for 1 function, we get this type of property. If images be same, then pre-image will be also same. Here in theory we see that set A contains elements A1, A2, set B contains elements B1, B2, B3. Image of A1 is B1, image of A2 is B2. But B3 has no pre-image. F3 is 1 function. But B3 has no pre-images. This type of function is known as 1 1 into function. And here we see that every elements of codomain has pre-image. So this is called 1 1 onto function. Now we come to 4. Let A and B be two sets. F4 is a function defined on set A to B such that image of A1 is B1, image of A2 is B2. Since F4 is a function, so for each element of domain we must have its image in codomain. So A3 must have an image in set B. Let image of A3 is B2. This is many one function. Here we see that number of elements of A is 3, number of elements of B is 2. So number of elements of A is greater than number of elements of B. In this case, we get many one function, but we do not get 1 1 function. So for getting 1 1 function, number of elements in domain cannot be greater than number of elements of codomain. Let we have a set A which contains element A1, A2, A3, and set B contains element B1, B2, B3. Phi 1 be a function such that image of A1 is B1, image of A2 is B2, image of A3 is B3. Here we see that number of elements of A and number of elements of B be same, that is 3. We write here elements of A and here images of all elements of A under corresponding element. Means image of A1 is B1, image of A2 is B2, image of A3 is B3. This phi 1 is one of the 1 1 function. Also we may get another 1 1 function if we write here B1, here B3, B2. This function may be written as here A, here B. Let that 1 1 function is phi 2, A1, A2, A3. Here image of A1 is B1. Here B1, image of A1 is B1. Image of A2 is B3. Here we write B3. Image of A3 is B2. This is another 1 1 function. Similarly, if we write here B2, here B3, B1, image of A1 is B2, image of A2 is B3, image of A3 is B1. Similarly, we may write B2, B1, B3. Also, B3, B2, B1, B3, B1, B2. Each row denotes a function. This denotes phi 1, this denotes phi 2, and in this way we get phi 3, phi 4, phi 5, phi 6. So we get 6 numbers of 1 1 function. These all functions are 1 1 function. This is done by getting permutations, means interchanging their places. Here we have 3, So 3p3, that is factorial 3. Factorial 3 means 3 multiply 2 multiply 1, that is 6. 6 number of 1 functions. So if a number of elements of A equal to number of elements of B equal to m, then number of 1 functions will be factorial m. If a number of element of A equal to m, number of elements of B equal to m, and m greater than n, then we may get 1 in 2 functions. For example, here A, here B. Let psi be a 1 function, here A1, A2, here B1, B2, B3. If psi is 1 function, then image of A1 is B1, image of A2 is B2. Let. Then B3 has no pre-image, but psi is 1 function. So for getting 1 function, we have to take 2 elements out of 3 elements of B, and then we take permutations, means exchange of the position of the elements of B. So in this case, we select n elements out of m elements of B, and then we mutually exchange their places. So number of ways equal to mcn multiply, this is number of ways to select n elements out of m elements, and simultaneously we exchange the places of n elements, that is factorial n. This is equal to factorial m by factorial n multiply factorial m minus n multiply factorial n, and this is equal to factorial m by factorial m minus n, and this number of ways be the number of 1 functions. Therefore, number of 1 functions will be equal to factorial m by factorial m minus n. So our problem is solved. Thanks for watching my video. If you are satisfied with my presentation and contents, then please click on like button and do subscribe my YouTube channel. Thank you.